Welcome to math class. Uh, in today's class, we are going to look at the last method that we are here to discuss of solving simultaneous equation, and that is the graphical method. Okay, so we are going to look at how we can use our graph to plot or to solve and find solution of a simultaneous equation. We have a video on linear graph, how to plot a linear graph. So I will advise that you go back and check out how to plot that graph, because a whole lot was explained on how to plot a linear graph. Okay, so today we are going to look at how we can plot a simultaneous equation graph and use it and find our solution. In the linear graph that we did in previous class, we looked at two different methods of plotting a linear graph. Okay, we looked at two different methods of plotting a linear graph. So in this class today, we are going to look at the simultaneous equation graph, linear simultaneous equation graph, using those two different methods of plotting a linear graph. So it means that one of the graph will make use of table, while the other will not make use of table. So let us start now. Let's say we have a problem to solve. Three x minus y equal to 12 and x plus 2y equals to minus 3. Okay, so this is the two equations that we have to solve using graphical method. So I'm going to use the method one, the first method, which is creating the table of value before we can be able to plot our linear equation. Remember what I say in that class, that you don't need to have up to 5 or 7 values of x. You can just get up to 3 or 4. That will help you to plot your graph. So let's call this one equation 1 and call this one equation 2. So we are going to create the table for equation 1, and we are also going to create the table for equation 2. So let us do that. For equation 1, we have our x and our y. So let's create our table. 1, 2, 3, and 4. So let's just use these four uh, values of s to find the corresponding values of y. So I can go to my rough sheet, okay, and solve for equation 1 at s equals to 1, at s equals to 2, at s equals to 3, and at s equals to 4. So that will give me 3 into 1 minus y. Okay, let's cancel this. Make, first of all, since I'm looking for y, I can first of all make y subject of the formula. So that will give me 3x minus 12 equals to y. So with that now, when s equals to 1, that will give me 3 into 1 minus 12 equals to y. That will give me 3 minus 12 equals to y. That will give me 3 minus 12 will give me minus 9. So minus 9 equals to y. So the first y there is minus 9. Okay, so the second one, when s equals to 2, we have 3 into 2 minus 12 equals to y. 3 into 2 minus 12 equals to y. So this will give me 6 minus 12 equals to y. So this will give me minus 6 equals to y. So our second value of y is minus 6. So when s equals to 3, we have 3 into 3 minus 12 equals to y. So this one here is when s equals to 1. This one here is when s equals to 2. Here is when s equals to 3. So that will give us 9 minus 12 equals to y. That will give me minus 3 equals to y. So I'll come here and put my minus 3. Now when s equals to 4, I'll have it as 3 into 4 minus 12 equals to y. So that will give me 12 minus 12 equals to y. That will give me y equal to 0. So I'll put my 0 here. So I have gotten my table for equation 1. So I will need to create another table for equation 2. I will try as much as I can to use the same range of values so that when we are picking our scale and other things, there will not be any confusion. So for equation 2 now, so just like what we have done here, we have to also do it here. So we have x, we have y, 1, 2, 3, and 4. Okay, so we have it as, we'll partition it to look like a table. So now we have x plus 2y equals to minus 3. So we actually need to, just like what we did here, to make our y subject of the formula. Okay, so we need to do the same thing here. So to do the same thing, I will have it as 2y equals to minus 3 minus x. So y will give me minus 3 minus s all over 2. That is when you divide both sides by 2. So with that now, I will say when s equals to 1, so when s equals to 1, I will have it that y equals to minus 3 minus 1 all over 2. So that will give you minus 4 over 2. So that will give you minus 2. Okay? Then when s equals to 2, I will have that y equals to minus 3 minus 2 over 2. So that will give us minus 5 over 2. That will give us minus 2.5. And when s equals to 3, that will give us that y equals to minus 3 minus 3 over 2. So that will give us minus 6 over 2, and that will give us minus 3. And when s equals to 4, our y is going to give us minus 3 minus 4 over 2. That will give us minus 7 over 2. That will give us minus 3.5. So we have gotten all our values for y. So let's replace them. When s equals to 1, we got that y equals to minus 2. So I'll come here and put my minus 2. When s equals to 2, we got that y equals to minus 2.5. So minus 2.5. When s equals to 3, we got that y equals to minus 3. When s equals to 4, we got that y equals to minus 3.5. So we have gotten the table for equation 1 and we have gotten the table for equation 2. So the next thing here now is to go and plot the straight line for equation 1 and straight line for equation 2. Then I will now explain how to use that graph to be able to find the solution to this problem. So if you look at the nature of the values that we have in our two tables, you will notice that y does not have any positive value, both in equation 1 and equation 2, for x equals to 1, 2, 3, and 4. So we are going to likely bring our graph a little bit up so that to accommodate up to -9. So let's see how that goes. So let's first of all draw our x-axis. Okay, draw our y-axis first. Now, because we don't have much of positive y, so let's see if we can bring our graph up so that we can have it as 1, 2, 3. I mean our scale, so that it can go as 1, 2, 3. So let's say -9, -9, 8, 7, 6, 5, 4, 2, 3, 2, 1, 0. So let's have it up here and see what we are going to get. So I have my 0. So let's take it as 1, 2, 3, 4, 5, -1, -2, -3. So here is 1, 2, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So here is our positive x, our positive y, our negative x, and our negative y. So if you look at this graph now, our scale here is that 2 cm. The 2 cm represents 1 unit on the x-axis, and the 2 cm also represents 1 unit on the y-axis. So we can write that, but let's be sure that this graph will give us what we want. Now, when we plot, we look after where these two lines are going to meet. So at the point that these two lines meet, that is the solution to the simultaneous equation. So sometimes we normally face challenge while plotting this graph because we are not sure where the two lines are going to meet. So we just plot. Sometimes they'll meet outside our graph. Okay, so when they meet outside our graph, what it implies is that we are going to draw the graph again and reduce the scale. When you reduce the scale, it will be able to get to that point that the two lines intersect, which previously met outside your graph. So is something that we have to be very careful about. Okay, that's why sometimes to take this kind of scale of 1 to 1 and 2 cm to 1 unit is not always advisable. Yes, it will make your graph and make your plotting to be easier, but sometimes the two lines are going to meet outside the uh, outside the four corners of your graph. But let's hope that this will not give us such. So the equation 1, when s equals to 1, y equals to -9. So this is our 1, this is our -9 for y. So where they meet is at this point. When s equals to 2, y equals to -6. So here is 2, here is -6. So where those two lines meet is at this point. The other one is when s equals to 3, our y is -3. So here is minus 3, here is 3. So you take it down and it will meet at this point. So the next one, when s equals to 4, y is 0. So 4 and what? 0. So with the points that we have, we join it. So you can see our ruler is not long. That's why it is advisable to use a long ruler. So I guess I'm going to get my long ruler. So let's join the points. Please make sure that you are getting the point. Okay, so you can see my straight line. So this one here is for 3x minus y equal to 12. So this is the line. So we are done with the first equation. So let's come to second equation. Second equation, when s is equals to 1, y equals to minus 2, which is here. When s is equals to 2, y is equals to 2.5. I have shown you how to count that. And if you check 1 unit, so it's going to give us the same thing that we did in the last one. So which is the tiny lines, how to calculate the tiny lines. 2 cm to represent 1 unit. So the tiny lines will be 1 divided by 10. So that will give you 0.1. So when you are here at 2, that's for this one. You are here for 2. I'm talking about this. So you now need to get 0.5. So you now move 2.1 minus 2.1 minus 2.2 minus 2.3 minus 2.4 minus 2.5, which is here. So at 3 is minus 3. So 3 is minus 3. Of course, we have gotten something like that here. At 4 is minus 4.5. At 4 is minus 4.5. So we'll do the same thing. 3.5, sorry. So at 4 is minus 3.5. This is minus 3 here. Okay, you can see it. Minus 3, minus 3.1, minus 3.2, minus 3.3, minus 3.4, and minus 3.5. So we have gotten our 4 points. So we need to use our ruler now to draw a straight line joining these 4 points. Please, like I always say, be careful with the points so that you can be able to get a straight line. Okay. So this is my second line, which is for s plus 2y equal to minus 3. So we have gotten our two lines. Okay, we have gotten our 2 lines. Now the question now is, how can we get our solution using this graph? Remember, the topic is graphical method of solving simultaneous equation. Okay, so that's linear simultaneous equation. Now when you have plotted the first line, when you have plotted the first line and you have plotted the second line, the point by which the 2 lines meet is where our solution lies. What is the s value at this point? What is the y value at this point? If you trace this point down to the s axis, you will get 3. That means our x, the solution of our graph, our x is equals to 3. And now if you also trace from this point to the y-axis, you will get your y as minus 3. So what you have there, x equals to 3 and y equals to minus 3, is the solution to this simultaneous equation. Is the solution to this simultaneous equation. So You can see how we have used the creating of table of content to solve this problem. So the next thing we are going to do now is to use the second method that we used in linear graph to see if that can work in plotting simultaneous graph. Okay, so in this second example, we are going to use the second method of plotting your linear graph in solving this simultaneous equation. Remember, in this previous one, we first of all constructed a table of value. Okay, that's it here. We constructed a table of values, okay, for values of s and the corresponding values of y for the two equations. So these were equation 2 for the two equations, okay, so for equation 1, for equation 2. But here in this next method, we don't need to do this table of values, okay. All we need to do is to find the value of s when y equal to 0 and the value of y when s equals to 0. So let's take this example 2. For 2, we have 3s plus y equal to 6 and x plus 2y equals to 5. Okay, so like I said, if you have not watched the way we plotted a linear equation, please, I think it's the right time to move back to go and watch this video, go and watch that video, and you come back and see what we are going to do. Because what we did in that video, in the second method, is actually what we are going to do here. So, what is it that we normally do? We find the value of y when s equals to 0 and find the value of s when y equals to 0. Okay, so we find the value of y when s equals to 0 and find the value of y when s equals to 0 and value of s when y equals to 0. So we are going to do that for the both equations. So this is for equation, and we are also going to do that for equation 2. Okay, so we are going to do our rough sheet here, then we now plot our graph. So let's try that out. So when s equals to 0 in equation 1, what is going to be y? So we have 3x plus y equals to 0, equals to 6. Okay, 3s plus y equals to 6. Now when s equals to 0, we have 3 into 0 plus y equals to 6. So this one will go y equals to 6. So we'll write it out here. Then when y equal to 0, let's find the value of x. So that will give us 3x plus 0 equals to 6. This one will go. So that will give us 3s equals to 6. Divide both sides by 3. You have that x equals to 2. So we have gotten this. Now let's come to the equation 2. Equation 2 is x plus 2y equal to 5. So when y equal to 0, I'll have 0 plus 2y equal to 5. So this will go, I have 2y equals to 5. Divide by 2, divide by 2. This and this will go, y equals to 2.5. So I have it as 2.5 here. So I will do when y equal to 0 now. So I have x plus 2 into 0 equals to 5. So this one will go, s will give us 5. So with these two sets of values that I have for both equation 1 and equation 2, I'm going to go to my graph now and plot these two straight lines and see what we are likely to have. Okay, so this is my graph. Okay, this is my graph. So let's rule the lines. So we don't have much huge numbers, and like I said in the previous example, we don't know where it's going to meet. Okay, so we just plot and hope that it will meet very close within our graph. So we draw our line. So okay, so this is our graph that is ready for plotting. So we have our x-axis, we have our y-axis, our negative s-axis and negative y-axis. So this is our point that we need to plot. So when s equal to 0, y equal to 6, so that's here. And when y equal to 0, s equal to 2, so which is here. So we need to connect those two things with a straight line. Remember what I recommended, a long ruler, though I'm using a short one, but a long ruler saves you from a lot. Okay, so you can see my straight line. So I told you to write the equation. So this is 3x plus y equal to 6. So that's our equation 1 straight line. Okay, so the next thing we need to do is to plot our equation 2 straight line. Okay, equation 2 straight line. Equation 2, when s equal to 0, y equals to 2.5. So the way we have explained about this number, so let's count 2.1, 2.2, 2.3, 2.4, 2.5. And when y equal to 0, s equal to 5. So that's here. So we join the two, this and this. Okay, so you can see that we have joined these two, and you notice that it meets at a point which is here. Okay, that's where it meets. So what are we going to do there? We trace this number down, so that's here, and we trace it sideways, that's here. So we need to know the value of each of those points. Here is 1, 1.1, 1.2, 1.3, 1.4. So I have 1.4. Then here is 2.1, 2.2, 2.3, 2.5. Oh, that's not where this is where we are looking for. So that will give me 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7. Okay, so it's between 1.7 and 1.8. So we can take it as 1.75. Okay, remember these are approximated value. So with that now, we can now say that our x is equal to 1.4 and our y equal to 1.75. So that's the answer using that second method. We are here to write our equation for the second method. X plus 2y equals to 5. Okay, so you can see how we have done that. So I will encourage you to get your graph. Okay, follow how we have plotted this uh, simultaneous equation in a graph, and choose a method, which of the method that you prefer, and stick to it. Okay, in mathematics there are always different methods of solving a particular problem. Just stick to a particular one that you are good at, use it and solve so many problems as much as you can. Okay, so I will see you in the next video. On that graph, the next topic we are going to look at is quadratic graph. So we are going to look at how this is a straight line graph, simultaneous graph. So we are going to look at quadratic graph. Then we are going to look at one linear, one quadratic simultaneous equation, both other method of solving it, and also how to use graph to solve it. Thank you very much, and I will encourage you to subscribe to our channel and share our videos. See you in the next class.